Okay, we're going to look at some equations today from section 7.6. We're going to skip 7, 3, 4, and 5, and we'll come back to it. So this worksheet is in the content library in your notebook, so you can follow along with me if you need to as we go. And we're going to start with number 1. All of these equations have radicals in them. In other words, they'll either be a square root or a cube root or a fourth root or something to the 3/2 power or something like that. So all of these equations will have radicals in them. So we're going to start with number 1. Notice number 1 has a radical in it, but the variable is not inside the radical. So we're just going to have to solve for x. So I'm going to subtract 3 from both sides. And then remember, I'm solving for x, so I'm going to divide both sides by 2 times the square root of 3. So I get x equals, I get 1, and reduce my 2/2, so I get 1 over the square root of 3, and we always remember to rationalize our denominator. So our solution is square root of 3 over 3. Okay, so in this example, the variable is not inside the radical, so we really don't have to do anything differently. So let's look at number 2 now. And in number 2, we have radicals in our equation, and notice that the variable is inside the radical. So in order to solve for x, we must get rid of the radical. And in this case, it is a square root. So we remember that the opposite of square root would be to square it. So that's what we're going to do. We're going to square both sides, because we remember that the square root of anything squared is itself. So if we square a square root, it's like opposite operations. They cancel each other out, and all I have left is 12 minus x. The square root of 12 minus x squared is just 12 minus x. And then on the other side, I have the square root of x plus 6 squared, which is just x plus 6. And then I'm ready to solve my equation. So I'm going to add x to both sides, add my like terms. X plus x is 2x. Move the 6 over. And so this equation is not difficult. Divide by 2, and then I get 3. Now the problem, go back up to the instructions, the problem with solving equations that have radicals in them, when the variable is inside the radical, is we have to check for what's called extraneous solutions. An extraneous solution is a solution that we get when, get my red pen here, a solution that we get when solving an equation that doesn't actually make the sentence true. So we always have to make sure we check our solutions when we're solving a radical equation. So I'm going to plug 3 back into the equation to see if it makes the sentence true. I get the square root of 9 equals the square root of 9. Check. 3 is our solution. Okay, let me get my black pen back. Okay, let's go to number 3 now. Okay, so we're going to do exactly the same thing here for number 3. Notice where the variable is. The variable is inside the square root, so I need to get that square root by itself first. So I'm going to get the square root by itself first. Subtract 1, divide by 2. Get the square root by itself first. So I get the square root of 3x plus 4 is equal to 7. Now I'm ready to solve for x, and notice where the x is. The x is inside the square root. So what I'm going to do to get rid of the square root is I'm going to square both sides, because I remember that the square root of anything squared is itself. So the square root of 3x plus 4 squared is 3x plus 4, and 7 squared is 49. Then it becomes a pretty easy equation, a little baby equation. 3x equals 45. So we divide by 3, and we get 15. And then we always want to make sure that we check our solution. Get my thin pen here. So we're going to plug 15 back into the equation to see if it makes the sentence true. So I get 2 times the square root of 49 plus 1 is equal to 15. And the square root of 49 is 7. 7 times 2 is 14, and 14 plus 1 is 15. So check. 15 is the solution. Okay, let's go to number 4. We're not going to do number 4 because number 4 is exactly the same. And we're going to look at number 5, and I want you to notice that if I add one of these square roots to the other side, then it becomes exactly like number 2. So we're not going to do that one either. I'm going to go ahead and let you do that one on your own. So we're going to add the square root of 5x minus 4 to both sides. So we get the square root of 21 is equal to the square root of 5x minus 4. And it's going to become exactly like number 2. 5. Yes, number 5 and number 2. Okay, so we're going to move on to number 6. Okay, number 6 doesn't look like it has a radical in it, but it actually does, because x to the 3 over 2 power is the same thing as the square root of x cubed. So we're going to get that radical by itself first by dividing by 4. And we do not, 32 divided by 4 is 8. We do not need to change this into radical form. What we need to do is remember that we want to solve for x. In other words, we want it to say x to the first power. So the way that we're going to do that is we're going to raise this power to another power. We're going to raise it to its reciprocal so that I can multiply my exponents and say 3 over 2 times 2 over 3 is 1. So I'm going to raise both sides to the 2/3 power. X to the 3 over 2 raised to the 2/3 is just x, because we multiply our exponents and we get 1 there. And we get 8 to the 2/3. Now we remember that 8 to the 2/3 is the same thing as the cube root of 8 squared. So the cube root of 8 is 2, and 2 squared is 4. And then we got to check. So we're going to check our answer. We're going to plug it back in. 4 times 4 to the 3 over 2 is equal to 32. Let's see. 4 to the 3 over 2, that's the square root of 4 cubed. So the square root of 4 is 2. 2 cubed is 8. So we get 4 times 8 is 32. Check. Okay. Okay, so I'm going to do one more with you. And then I'm going to let you try these on your own. We're going to go to something a little bit different, which is number 10. Okay, number 10 has two radicals just like number 2. So we go back to number 2 and we notice that number 2 had two radicals, but they were both on opposite sides of the equal sign, and then I squared both sides. So I'm going to do the same thing here in number 10. I've got two radicals. They're both on opposite sides of the equal sign, so I'm going to square both sides. The problem here, well, let's do the left side first. The square root of x minus 5 squared is just x minus 5. And the problem with the right side is I've got a binomial to square. And we remember that when we square a binomial, we either do FOIL. Let's do that. Let's do FOIL. 2 plus the square root of x times 2 plus the square root of x is, let's see, first, outside 2 square root of x plus inside 2 square root of x. Last, square root of x times the square root of x is just x. Okay, so let's see. Oh, look, I see I have like terms, so I can subtract x and get rid of that. So I get negative 5 equals 4 plus, and then I've got like terms. 2 times the square root of x plus 2 times the square root of x is 4 times the square root of x. So now I end up with the equation, and I was trying to get rid of my square roots, and it didn't happen. I still have a square root in it. So, but now I only have 1 instead of 2. So when that happens, I have to get that radical by itself. So I'm going to subtract 4 from both sides and then divide by 4. So I get the square root of x is equal to negative 9/4. And so I know the last step would be to square both sides because I want to get rid of my square root. So the square root of anything squared is itself. And then I get positive 81 over 16. Now when I go back to plug it in to check, it's not going to make the sentence true. So this is what we call an extraneous solution. And the reason why it is extraneous is because when I squared both sides, I squared a negative. Look back up at the step before it. I squared both sides and I made a negative positive, so I changed the sign. So when that happens, I'm going to end up with an extraneous solution. So if you end up with that, you're just going to cross it out because it doesn't make the sentence true, and you're going to say that there is no solution. Okay, so I want you to try 4, 5, 7, 8, 9, and 10. and see how you do.